Hello students, how are you? Good evening. So, firstly, tell me about my voice is clear to you and the screen is visible to you. If so, please write this thing in the chat box, and we will wait for what 1 or 2 minutes more. Let the other students to be joined. Okay. So please make sure the screen is visible to you and I'm audible to you. Got it? So till then, uh, let me discuss the topic that I have covered in semiconductor. In the previous lecture, we have seen about the p-type semiconductor and n-type semiconductor. These are nothing but the doped semiconductor. Okay. Extrinsic semiconductor we will study. We have studied so far. Hmm? There are two types of semiconductor. First one is intrinsic semiconductor that is naturally found, which is silicon and germanium. But they have no significant use in their natural state because their conductivity is very low at the room temperature. Okay, so that is why we need to do some extra efforts to make them more conductive at room temperature so that we can use it for the purpose of many electronical devices that we made. Okay, so for that, if we want to use them as a device to make the another device of semiconductor, the electronic device that we are using, so we would have to make them more conductive at room temperature. So for that purpose we doped or we inject some impurities into that silicon or germanium. Okay, so let me tell you firstly. So here the lecture number 4 we are going to cover today. Okay, firstly we will discuss what we are going to do today. So the learning objective for today is PN junction formation. Till then we have studied individual PN type of semiconductor. But what is the problem that PN type semiconductor individually has a very limited uses. Okay, so what we are going to do, we just combine them and form a PN junction diode. Okay, and we will see that how this formation going on, how this formation happen, what is the working of this diode. Okay, like how the formation has, what is the working of this diode, and what is the PN junction diode work with forward bias and reverse bias. And these all parameters, these all terminology, I will discuss one by one. So do not worry about it. What is forward bias? What is backward bias? Do not confuse with it. Okay. So we will discuss it one by one. Now, if I recall something, so in the previous session, we have learned that there are two types of semiconductor, two types of semiconductor. The one is intrinsic and another is extrinsic. Extrinsic itself has two type, which is p type and n type. Okay. Intrinsic semiconductor is also known as doped semiconductor. Semiconductor. Okay. So this doped semiconductor has two types, p type and n type. How is this doping possible? It is the injection of impurity. Okay. In p-type semiconductor, the majority charge carrier. So what is the majority charge carrier in p-type semiconductor? It is holes. Okay. And in n-type semiconductor, the majority charge carrier are electrons. Okay. In p-type semiconductor, what kind of impurity we will use? So is the screen is visible to you? Every one of you? Hitashri, Hoysala. Is the screen is okay? Okay. So sorry for the technical glitch. Okay. So where we are? We are on the recall part. Okay. So what we are discussing here is that a p-type semiconductor P-type semiconductor, P-type semiconductor is doped with trivalent impurity. Trivalent impurity. Okay, I have already discussed this in the previous session, but I am here discussing it for the recall part. Okay, so that you will revise it. And for N-type semiconductor, the doped impurity, it is doped with what? A pentavalent impurity. Pentavalent impurity. Because pentavalent impurity gives excess electron and this will give excess hole. And hole is considered to be positive, so that is why it is a positive type semiconductor, and the majority charge carrier here is hole, and here the majority charge carrier are electron itself, and the pentavalent impurity gives excess electron, so it behaves as the n type semiconductor, negative type. Got it? Now what is a p-n junction formation? Let we discuss it. So when P and N type semiconductor are joined, then whatever is formed because of that junction is called as the p-n junction. Okay. So in this definition, you will see when a p-type and n-type semiconductor are joined such that the crystal structure remain continuous at the boundary. Remain continuous at the boundary means there can be a flow of electron to hole or hole to electron, which means the electron, the charge carrier, the majority charge carrier or the minority charge carrier can flow through the p-type semiconductor to n-type and n-type semiconductor to p-type. That is the meaning of this continuous at the boundary, continuous crystal structure at the boundary. And this resulting arrangement is called the p-n junction diode. Now, why it is named as diode? Why it is named as diode? Why not other names? Look, you can consider this p-type. This is the p-type semiconductor, and this is the n-type semiconductor. Okay, this p-type semiconductor you can consider to be positive. In positive, we would consider it as anode because the positive plate is considered to be anode and the negative plate is also considered to be a cathode. In battery also, the positive terminal is termed as anode and the negative terminal is termed as cathode. Okay, and these are electrodes. Okay, in battery you will see two electrodes, one is positive, one is negative. So the positive one is called anode and the negative one is called cathode. Now in p-n junction we have diffused two types of semiconductor, which is p-type and n-type. So we have diffused two electrode, one is positive and one is negative. Two means dia, di, di means two, and we have taken this ODE term from this electrode. So diode, which means we have two electrodes in this combination. Okay, that is why it is termed as diode. Now you are better understanding it, why we are using this term. Okay, so this is only for your information. If anyone asks you that why we named it as diode, so you can tell them that In diode we have two electrodes because the p type and n type semiconductor itself on self behaves as an electrodes, which is positive electrode anode and negative electrode cathode. So we combine them, so two electrodes are combined, we take die for two and odd from the electrodes, so it means, and we will combine it, so it will form diode. Got it? Now this is the P and N type of semiconductor. I have basically shown here the majority charge carriers, not the minority charge carriers. And why it is so? Because minority charge carrier, the current produced by the minority charge carrier is very less in comparison to the current produced by the majority charge carriers. Got it? So that is why I am representing here it as the impurities. So in P type semiconductor, the impurity will be plus, because there will be a vacancy, aluminum, trivalent impurity, and in N type semiconductor, this impurity will be negative. These are the negative ions, but they have excess electron itself. Okay. Now, when they form, so here holes are the majority charge carrier, and you can take this color. So this is the hole. So this hole in P-type semiconductor, holes are the majority charge carrier, and these are the trivalent impurity, as I've already discussed with you. This represents the free electrons or electron, and these are the majority charge carrier in N-type semiconductor. Okay, and these green dots are nothing but the pentavalent impurity. So majorly I have shown the impurities itself, not the minority charge carriers. Got it? Now, how this junction will be formed? Let us look. The whole arrangement initially, if we put this p and n type semiconductor together, so initially the system will remain in equilibrium, or you can say it is electrically neutral initially. Then what will happen? Now, what will happen at the junction? You will see this dotted line here. This is the junction of, you can say it is the junction of this diode. Okay, where the P and N type separate from each other. So this is the junction between them. So at junction, what will happen? This electron can jump into this hole easily. This electron can also jump into this electron. So when this happen, so this vacancy is created by the breaking of covalent bond. This vacancy is nothing but the breaking of covalent bond. So when this electron jump into this vacancy, jump into this vacancy, so this covalent bond complete itself, which means there are only the ions that remaining here, because this is the trivalent impurity. So trivalent impurity may we have one vacancy, all the three electron will be paired, but there is one vacancy, and this one vacancy is filled by this electron, which is provided by this pentavalent impurity. Okay, so only we have here the impurity ion itself, not the whole. Same goes for this pentavalent impurity initially has this electron, but this electron has filled this gap. So there is no electron, no excessive electron on the pentavalent impurity. So the only the this ion will remain itself. And because this is accepting the electron, this purple color dot is accepting the electron, so it will become negative, and this green color dot is donating the electron, reducing the electron from it, so it will become positive charge. So these are the only, in this region we have only this immobile charge. So these are the ions. Okay, so these are the ions that we have here only remaining. Got it? So let me summarize this. What will happen? Initially, there is the electrical neutrality will hold at the junction. But what will happen? This electron at the junction can jump into this vacancy. This is a possibility. This electron can jump into this vacancy. This electron can jump into this vacancy. So all the vacancies at the junction are being filled by the excess electron of the pentavalent impurity. And this vacancy is nothing but a vacancy created by the trivalent impurity. Okay? So all the vacancy are filled by the electrons. Since this pentavalent impurity atom is donating the electron, so when an electron donates the electron, it will become positively charged ion. Okay? And when an electron accept, when an atom accept the electron, it will become negatively charged. Okay? So all these trivalent impurity at this side in this region will become positively, sorry, negatively charged, and all these impurities present on the n side near about the junction will become positively charged. I hope you are clear with this. Okay. If you have any kind of doubt, you can ask right now. Okay. Now, due to the difference in the concentration of holes from p region diffuse into n region, and the electron from n region diffuse into p region, because in p region we have high concentration of holes, positively charged carrier. Okay, majority charge carrier in p type semiconductor is holes. So in p type semiconductor we have high concentration of holes, and in n type semiconductor we have high concentration of electrons. So electron want to fill from high concentration to low concentration, so they want to go to that low concentration level. Similarly, these holes are also trying to go from high concentration to low concentration for balancing. Okay, but you will remember one thing, only the electron is moving, not the hole. Okay, the only movement is responsible for this whole combination is for the motion of electrons. Okay, so now you can see these are the only thing, because in this region, if you will see carefully, in this region there is no electron and holes remaining. Okay, so because of this movement, because electron is moving from here to here, so a current will form here to here. This hole is moving this side to this side, so a current will also form in the direction of hole, because current is always in the direction of positive charge carrier. So there will be a current formed at the junction, which is called as diffusion current, because it occurs because of the diffusion of electrons into the holes. So that is why this current is termed as the diffusion current. Okay, now this is the first point. Due to the diffusion of electron and holes, now due to the diffusion of electron and holes, there is a layer forms of some width at the junction, at the pn junction. This diffusion current की वजह से the diffusion of electron and holes take place, and because of this diffusions there is a layer form at the junction. Why is this layer? Why is this layer forming? Because all the electrons at the junction, near about the junction, will fill have filled already filled the vacancies, already filled the vacancy provided by the trivalent impurity. So in this specific reason, you will see this is separated. In this specific reason, only the positive and negatively charged ions you will have. And these ions are very heavy in size, so they cannot move. Okay. So we can assign them a name which is immobile. Mobile means which can move, and immobile means which cannot move. So these are the immobile charged ions. Okay. What will they do? They will further restrict the motion of electron from n side to p side, and the motion of hole from p side to n side, because it is very tough for an electron to jump by its energy. Okay. Initially, we have not connected a battery, so only the electronic movement inside the material is taking place. Okay. Whatever energy they have for that. So when this barrier formed, when this at PN junction, when this barrier has formed, this electron find a very hard path to cross this junction, and it is very tough for an electron to move through these heavy ions. Okay. So further diffusion will stop. Got it? And this barrier, this layer will act as a barrier. Okay. Got it? And this layer, which is pretending, which is acting as a barrier for the electron and holes for the further diffusion, is termed as the depletion layer. Okay. So you can see here, due to the diffusion of electron and holes, a layer of positive charge on n side and a layer of negative charge on p side of the junction is developed. Okay. And this is called the depletion region or the depletion layer. It is also called as depletion layer, which deplete the flow, which restrict the flow of electron from p side, n side to p side, or flow of holes from p side to n side. Okay. So this charge region either side of the junction together is known as a depletion region or depletion layer. Now, if you can see here, due to this positive charge region here, here the positive charge carrier is there. So this is the positive charge and this is the negative charge ions I'm talking about, the region inside the depletion layer. Okay, so there are positive and negatively charged ions. So because of that, a electric field will be developed, and the direction of electric field from positive to negative charge. So electric field E is developed from positive side to the negative side, or you can say from n side to the p side. And this electric field oppose the motion of electron. Okay. Because for an n-sided electron, the electron present on the n-type semiconductor, and this electric field has been developed. Now, on this electron, this electric field apply a force in opposite direction. So it will restrict these all electrons moving from N to P in this direction. Got it? Now, so this electric field causes a difference of potential across the junction of two regions, and that is the junction. That is the difference of this potential. So from this region to this region, you have a potential difference, which is V naught. It is also termed as the barrier potential because it acts as a barrier potential. because it acts as a barrier for the electronic movement. Got it? Now you are understanding that if we are able to provide that much amount of voltage, that much amount of electric field provided by the external source, which is a battery, so there can be a possibility that electron can jump through this barrier. And you are thinking, if you are thinking so, you are thinking in a right way. Okay. Now, this potential oppose the movement of electrons from n region to p region. So I have already told you this n region electron want to fill this vacancy at p region. But because of this barrier potential, because of this electric field developed by this immobile charge, this E is electric field developed by immobile charged ions. Okay. So because of this, this electron will feel a force, will acted by a force in the opposite direction. So it opposes the motion of electron from n region to p region. So it is often called the barrier potential. Got it? Now, due to the electric field, minority charge carrier, we cannot miss that because there are minority charge carrier also there. Na? So these minority charge carrier, let's say here, okay, here are some minority charge carriers. In p-type semiconductor, yeah, we know that the majority charge carriers are holes, but the minority charge carriers are electrons. And this electric field will apply a force in this opposite direction. So this electron try to get into this depletion layer. Okay. And this here in n-type semiconductor, we already have holes. These are the minority charge carrier here in n-type semiconductor, minority charge carrier. So these electrons from p side, because there are minority in minority, but they exist na, they are not vanishes, they exist, but at the level of minority. And this electric field which is developed by this immobile charge and support this electron for p side, you can easily see. Okay. So due to this electric field, minority charge carrier electrons of p side of the junction moves to n side, and a hole on n side of the junction moves to p side. So any electron, minority electron, because of this electric field, move towards the n side, and any hole which is the minority charge carrier in n-type semiconductor move towards the p side because of this electric field. Okay. So for that, if this movement is taking place, so there definitely a current will be formed because electron is moving and hole is also moving. So there will be definitely will be a current. So this motion of minority charge carriers due to electric field is called drift. So remember this. This is called the drift. Got it? So initially, if I talk about the current due to diffusion is very large. Due to the current due to drift is small. Because initially what will happen? The depletion width will forming. So the majority charge carrier are in motion. Because the majority charge carrier of n type means electron are filling that vacancies very rapidly. So the diffusion current which is formed because of the diffusion of electron from high concentration to low concentration is very large, because this process is taking very less time to be happen. So there is a very large amount of current that will be flowing through it, which means initially the current due to the diffusion is large, and current due to drift, because they are always in there itself is in minority, so the current developed by them will be in small. Okay, so the drift current here will be small, and the current due to diffusion will be large. Initially, I'm talking about. Then what will happen? So this process continues until the diffusion current equals to the drift current. Okay. Initially, what will happening? These electrons are coming and diffusing into these vacancies from n region to p region. These electrons are diffusing into that. Okay. But this minority charge carrier facing a hard time to crack this barrier. But when the electric field has been developed, then this minority charge carrier will try to go into this side. And this will happen until this current, which means the drift current, equalizes its value to the diffusion current. Diffusion current. Okay. At that moment, when both the current will be equal, at that moment, the junction already been neutralized because there is no net current there. Okay. So we are again having a situation, there will be no net current. But now we have the electric field developed by the immobile charge. Okay. So this is the equilibrium state when there is no net current. Okay. Now, what is a semiconductor diode? I have told you that the semiconductor diode or PN junction diode is basically a PN junction semiconductor. P and N type semiconductor are fused with each other, and at the end of it, they have a metallic strip so that we can connect the battery and take the advantage of it. Okay. So these are the metallic strip connected to it, and this is the electronic representation of diode. This side you can consider to be this side to be positive. This thick arrow is considered to be positive, and this line here is termed as to be negative. So this end is positive and this end is negative. Okay. Now, what are the advantage of semiconductor diodes? So semiconductor diode has very much advantage in electronic systems that we are using today. So the very first advantage of it, that it will not produce a very significant sound when while operating. Okay. You have seen the other mechanical machines that will produce a large amount of sound that is unbearable sometimes. Okay. If you go to the factories, there are so much noise that the machines are creating there. So that is not the feasible working. Okay. Those this semiconductor devices that like the laptop you are using, the mobile you are using, they are operating all the time, but they are not producing any significant sound that you will get uncomfortable with. So this semiconductor diode, just a second, this semiconductor diode do not produce a humming noise during the operation. Humming means when there is a system and there is some unwanted noise that you don't want to hear, that kind of noise is termed as the humming noise. Okay. It's same when a bee means madhumakhi or makhi, whatever you can say. So when it moving up and down, circling your ear, so that type of sound is also the humming sound. It's like so that types of sound is humming sound. Okay. So the semiconductor does not produce that. The second advantage of it, the diode are set in the operation as soon as the circuit is switched on, which means there is no lagging of current. In the RC circuit and LCR circuit, you will see somehow in the LC oscillation circuit that there will be some lagging. Okay, there will be some lagging na, between current and voltage and all. But in diode, if you are using diode, as soon as you switched on the circuit, it will start flowing. The current will start flow. Okay. The very most important advantage is that their sizes, they are very compact. Okay. So you can assume that if you are using a 6 nm processor, you have listened to it na, when you wish to buy a phone, then you will also check it, the processor of it or the computer that you are using. Okay, 6 nm means 6 nanometer. Nanometer means 10 raised to the power minus 9 meter. Okay, so that small semiconductor we have fused to make this IC circuit. Okay, that is the processor. Okay, so look how compact they can be. So that is why we are having a very high speed of internet in today's. So semiconductor diode requires low voltage for their operation. Okay, not significant, because in your charger is also, you will see, I'm not saying your adapter is 120 watt or 44 watt or that. Just look at the back of it and you will see that there is a current in milliamperes, that the actual current provided by that adapter, that adapter to the mobile. And mobile is an electronic device which is made up of semiconductors. So semiconductor requires low voltage. Okay. Although you can check it out with the batteries, the battery used in mobile, how much it is? It is hardly from 1 volt. 1 volt is significant ho gaya. 0.5 to 0.7, 1.2 volt, 1.5 volt. है ना? Look how small the voltages are. ठीक है? So there is low power consumption. तभी एक चार्ज में मोबाइल 2-2 दिन चल जाता है ना? 2-3 दिन चल जाता है आराम से, अच्छे वाला मोबाइल जो होता है. It is because of, not because of the battery. It is, yeah, battery will play a role, but it is also the power consumed by the system. Na? The power consumed by the system is small. That is why this battery can work for a long period. The disadvantage of that is only when you just give the excess voltage to it, the temperature will rise and this will malfunction. It will burst out. And we usually heard about this term like IC फूक गई है इसकी, तो IC will blast, short circuit हो गया. It is happens because of the temperature rise when you rises the voltage, and it is not bearable for the semiconductors. That is why this you can take the disadvantage of. Okay? And actually it is not a disadvantage, it's a limitation of it. Okay? If you limit the temperature range, then you can have the advantages. All the things will be advantage to the. Okay? So this is the limitation of it. It is limitation. Now, if I talk about the PN junction diode under forward bias. Forward bias is nothing but when you have the diode and you apply an external power source to it and it flows the current. Okay? It will not restrict the current. It is having the current. It is showing the conductivity. So that situation is termed as the forward bias. See? This means movement of current is possible. Okay, or you can say it shows high conductivity. High conductivity. Okay. Now what will happen? You have the immobile charge ions and the depletion layer. Depletion layer is formed by the immobile charge ions, not carriers. They are the immobile charge ions. They cannot move. And this depletion layer is formed by these charges only. Okay. Now you can read it. When the positive terminal of the battery, if you connect the battery like this, the positive plate is always bigger. This is the representation of a battery. The positive plate representing the positive side of it means anode, and the small plate represent the negative side of it. So when you connect the battery in such a manner, then you connect the positive plate to P side of a diode, and the negative terminal of the battery to the negative side of the diode. Then it will result in the forward bias. Forward bias. Okay. Look at this examples. This is the electronic representation. This is the positive side. This is the negative side. So if you connect the battery such a way like this, so this is to be said in a forward bias. Forward bias. Okay. Now what will happen in the forward bias? They have already connected in ammunition. This battery is connected. The positive terminal of the battery is connected to the positive plate. The negative terminal of the battery is connected to the negative plate. This condition is termed as the forward biasing of electron. Okay. Okay. Then what will happen? In N type, we have majority charge carrier electrons. In P type, we have positive charge carrier electrons. So what will happen? Let's look. I will brief you about this. This is the depletion layer. Okay. Just a second. This is the depletion layer. These ends are connected to a battery. Okay. These are electrons here, and these are holes. This is P side and this is N side. Okay. So what will happen? This battery provides V voltage, which means it creates an electric field from negative to from positive to negative. So the direction of electric field will be in this direction. It is created by the battery. Okay. So what will happen? This electron will be repelled by this electric field, because an electron, if I applied an electric field in this direction, so the motion of electron will be opposite to that, because there the force acting on the electron will be F is equals to QE, and Q is nothing but minus E. So F here is negative in the direction. So this electron, if this field created by the battery is sufficient enough so that the electron can get through this depletion width. Okay, it can also get through this. The hole can also get through this. Okay, so there is a possibility that current can flow. Okay, now what will happen? Let's look into this. These are the electron, majority charge carrier, and these are the holes, the majority charge carrier in P type. Now, what will happen when the holes in P region are repelled by positive terminal of the battery? and the free electrons are repelled by negative terminal of the battery. So some holes and free electron enter into the depletion region and the width of depletion layer decreases. Okay, let me give you this explanation. This is the negative side, okay, and this is the positive side. Initially they have a width of like this. When electric field is developed here in this direction, so what will happen, the electron present here can jump into this, okay, can jump into this, which means this width got reduces because there is no further electron here. So this electron is causing the reduction in the depth, in the width of the depletion layer. Okay, so here there is hole. This hole is also trying to go to here. So this electron is combined with this hole here. Okay. So here there is no hole. So this depletion width is also decreasing from this side. So when in the forward biasing, the width of the depletion layer decreases. Okay. Width of the depletion layer decreases because of the movement of these electrons and holes. Okay, got it? So this depletion layer decreases. So initially, when V is 0, we have a potential barrier as V naught provided by this. Okay, when there is no external power source is used, so we have a potential barrier here, V naught. Okay, but when we apply a battery, when we applied a potential by a battery V, okay, so what is happening, this width of the depletion layer is decreasing. So width of the depletion layer is directly represented by this V node, which means after the application of battery in forward biasing condition, the width is reduced. So the potential barrier. So initially we have a value of potential barrier, but because of this forward biasing, the depletion width decreases, so the potential barrier is also decreasing. And you can see by the blue line here, initially we have a potential barrier here. If you take this reference, here we have, but when the forward biasing is applied, so it decreases the value by this amount. So the effective barrier height under forward biasing is V node minus V. Okay. Now, if we increase the applied voltage significantly, then the barrier height will be reduced and more number of carrier will have to require energy to cross the barrier. So it directly dependent on the potential that we are putting through this. Okay, the battery that we are using. If you using a high power source battery, high voltage battery, then the depletion with more compressed. Okay, so more charge carrier we will have, and if you are doing so continuously, so there will be no depletion width will be remain. So electron from n side cross the depletion region, reach p side, and holes from p side cross the junction and reach to n side, which means holes from here can jump through this and the electron from here can jump through this, and they can be easily attracted by these terminals, and the circuit will complete and there is a flow of charge can take place. Okay, so this process under forward bias is known as minority carrier injection. Got it? I hope you are got this. Look at this electron which is moving from here to here, because we have provided uh, sufficient amount of potential to make this electron jump through this barrier potential. So that is why it is completing the circuit. Just look at it again. This is completing the circuit. So we have a value of current in the circuit. Give rise to the current. Okay. So this total diode forward current is sum of the whole current, which is also responsible for the movement of current, and the conventional current due to electrons, because here the hole is also moving from p side to n side, and the electron is also moving from n side to p side. So the magnitude of this current is usually in milliampere. So it is a very low value. So the time is up. This p-n junction diode under reverse bias we will discuss in next lecture. Till now, if you have any kind of doubt, you can ask. Otherwise, the lecture has been over. Thank you so much for being attentive in the lecture. Okay. Thank you so much. Take care of yourself.